Alright, hi. This is Adam Nugent Rosenberger reporting, reading a book called U.S. Army Corps of Engineering. This is the only corps of engineering book there is. It's TI 850-02, Army Air Force AFMAN 32-11-25-1, 1st of March of 2000. Technical instructions for railroad design and rehabilitation. The headquarters of U.S. Army Corps Engineering Construction Division. Directory of Military Programs, Washington, D.C. 203141000. Technical instructions, railroad design, rehabilitation of copyrighted material in this document is identified as its point use. Use of copyrighted part of the document must have permission to copyright holder. Proof of public release and distributed unlimited. Record of changes indicated in 1-1, no date, location. The technical instruction provided the design of the construction criteria apply to the U.S. Army Corps Engineering Commands having military construction responsibility. The TI will be used for all Army projects and the projects executed for the military service work of the customers where appropriate. The living documents will be periodically reviewed, updated, and made available to use as part of the headquarters of the U.S. ACE for responsibility, technical criteria, and policy of the new military construction. The Kemp ED is responsible for administration of the TI system. Technical content of the TI, responsibility of the headquarters of the U.S. Army Corps Engineering, element discipline involved. Recommended changes to the TI, rationality changes should be sent to the headquarters of the U.S. ACE, Camp ED 20 Massachusetts Avenue, Northwest Washington, D.C. 20314-1000. TI are effective upon issuances. TI is distributed only the electrical media, the technical info interest site of the hnws.army-mil-techinfo-hem. Construction criteria basis systems maintained in the National Institute Building Society Sciences at nibs.org CCB. Hard copies of this instruction should be checked against the current electronic version prior to the issuing that the latest instructions are used. For the Commander, Dwight A. Burnick, PE, Chief Engineering Construction Division, Director of Military Programs. Rail Design Rehabilitation Table of Contents. Chapter 1, Purpose, Scope, Applicability, Reference, Content of this manual, supplementary material using the ARIMA Manual of the Railway Engineering Applicability of State and Commercial Railroad Standards Source of Assistance. Chapter 2, Determining Traffic and Load Carrying Requirements, Introduction, Traffic Type, Traffic Volumes, Wheel Loads, Locomotive Traffic, Attractive Effort, traffic terminal sources of traffic information. Chapter 3, establishing route of the profile alignment specifications, introduction to grade resistance, route profile, transition between grades, curvature resistance, effective grade, locomotive tonnage rating and trial rule and grade. Chapter 4, Route Selection, establishing control points of the potential corridors, reconnaissance, initial survey, train location, final location. Chapter 5, Rehabilitation, track bridges and terminals, definition, application, installation, requirements and facility evaluation, condition and evaluation, structural evaluation, operational evaluation, rehabilitation plan, final plans and speculation, construction on-site inspection. Chapter 6, Track Roadway Design, gradeways and track profile, horizontal curves, clearances, track structures, track design methods, ARIMA design procedure, subgrade, frost design modifications, drainage, geotextile, ballast, sub-ballast ties and ties spacing, rail, other track material, turnouts, crossovers, track connections, ladder tracks, rail crossing, miscellaneous track appliances. Chapter 7, Road crossings and bridges. Chapter 8, Introduction, Sitting, General Layout, Track Design, Clearance, Usable Track Length, Vehicle Terminals, Brake Bolt, Small Cargo Terminals, 7 Containers, 8 Ammunition Terminals, 9 Pole Terminals, 10 Interchange, 11 Yard Storage and Auxiliary Tracks, 12 Miscellaneous Buildings, 13 Security Fencing. Chapter 9, Construction, 1 Construction Surveys, Inspection, Materials, 3 saving salvageable materials, 4 subgraded drainage, 5 track construction, 6 quality control and quality assurance, 7 as-built and final drawings. A's reference Appendix A, reference. Appendix B, ruling grade example problem. Chapter C, simple track rehabilitation report. Figures common for 2-1 common freight cars, 3-1 common curves, 5-1 example turnout inspection, 6-1 typical cross section tangent track, 6-2 typical cross section sub ballast layered tangent track, 6-3 typical cross section curve track, 6-4 typical cross section sub ballast layer curve track, 6-5 typical cross section track with adjacent service road, 6-6 typical construction typical cross section of tracks geotextiles, typical cross section sublayer track of geotextiles, clearance of the diagram engine track, 6-9 locational clearance points, 6-10 example load distribution along the track, 6-11 example vertical pressure reduction through the track, 6-12 maximum track deflection long-term performance, 6-13 design wheel configuration, 6-14 general method determining the accessibility of soils, 6-15 design air freezing index North America, 6-16 air freezing index service covered frost penetration relationship, 6-17 required substrainage where only the side ditches can be installed, 6-18 geotextiles installation under a turnout, 6-19 geotextile installations at a bridge abutment, 6-20 anti-splitting devices for tie-ins, 6-21 tie plates, 6-22 recommended minimum railway anchor application, 6-23 rail anchors, 6-24 rail anchors application of the open deck bridges and railroad crossing, 6-25 general arrangement of turnouts and crossovers, 6-26 parts of turnout, 6-27 determining frog number or turnout size, 6-28 turnout design, 6-29 diverging route connection, 6-30 ladder track layout, 6-31 location of derails, 7-1 typical type of 1 gravel crossing for the timber flangeway header, 7-2 typical type 2 timber crossing, 7-2 7-3 typical 3A asphalt crossing, 6-7-4 typical 3B asphalt crossing with timber flangeway headers, 7 typical 3C4 railway asphalt crossing, typical 7-6 typical type of 3D 6 railway asphalt crossing, 6-7 typical 4A casting in place and concrete crossings, typical 4B prefabricated concrete paneling crossing, typical 7-9 typical 4C sectional monolithic concrete no ties, 7-10 typical type 5 full depth rubber crossing, 7-11 rubber flangeway fillers, 7-12 lagless concrete panel crossing, 7-13 typical geotextile subdrainage installation for vehicle road crossing, 7-14 typical drainage at road crossing, 17-15 recommended track construction of road crossing, 7-16 recommended crossroad approaching profile, 7-17 clearing cross visible areas approaching vehicles, 7-18 clearing of the cross visibility or stop the vehicles, 7-19 copper load reconfiguration bridges, 7-20 variation of copper E value with the span length, 7-21 loading diagram for the train of 100-ton 100-ton box cars, 8-1 typical small yard storm drain, 8-2 vehicle terminal, 8-3 track approach road lengths for the vehicle loading, 8-4 concrete and end ramp, 8-5 portable multi-level ramp, 8-6 control concrete side ramps, 8-7 interchangeable yards, 8-8 auxiliary tracks. Tables. Table 2-1 common car types and loading requirements. Table 2-2 common car types of design wheel loads. 3-1 grade design criteria for the main running tracks. 3-2 recommended minimum grade lengths. 3-3 curve design categories of minimum running tracks. 3-4 curve compensation at 1% grade. 3-5 estimating locomotive traction effort. 3-6 design gross car weights. 6-1 recommended transition rates for the grades and main main running tracks. 6-2 design super elevation curved track over 6-3 overheaded side clearance of the tangent track. 6-4 clearance increasing adjacent curved track. 6-5 track center distances. 6-6 suggested design track module values. 6-7 rail sections. 6-8 recommended ballast graduations. Table 6-9 switch ties for standard turnouts. Table 6-10 dimension services specification for relay or second hand rail. 6-11 Common joint bolt diameter 612. Turnout size selection criteria. Table 7.1 recommended crossing surfaces. 7.2 Table 7.2 clearance visible distance at road crossing. 7.3 Table 7.3 recommendation of copper design load of bridges. 9.1 suggested stake intervals for final survey. Table 9.2 rail joint gap. Chapter 1